Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today and right off the bat we've got something weird. Step 1, there's nothing there. But here's step 2 and here's step 3. Your challenge is to predict the number of squares that would be in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video, give it a try. Okay, I don't think we've seen a pattern with nothing for step 1, with 0 of something in step number 1, but I don't think that should discourage us. We can still figure this out. You're not going to get much information from looking at step 1 because there's nothing there, but step 2 and 3 are a little more easy to understand or visualize. This looks like a box with one square taken away. This also looks like a box with one square taken away. And if the square wasn't taken away, this would be a 2 by 2 box. This would be a 3 by 3 box. So if I'm going to predict the next step, I would think this would be a 4 by 4 box with one square taken out. Now, this actually works with the first step, right? So if we followed the same pattern, we'd have a 1 by 1 box, and then we'd take that away because we're taking away one box each time. So let's see, how many squares would this be? How many boxes would this be for step number 4? 4 by 4 is 16 minus one little square is going to be 15 squares. So that's my prediction for step 4. Now, we have a pattern of squares growing in 2 dimensions. So I'm guessing this is not linear. I'm guessing it's quadratic. But let's go ahead and analyze the numbers to verify that. So I'm going to make a chart with the step number and the number of squares. So in step 1, we've got 0. In step 2, we've got 3. In step 4, we've got 8. And in step 3, we've got 8. And in step 4, we've got 15. So we'll take the difference between each step. So 3 minus 0 is 3. 8 minus 3 is 5. 15 minus 8 is 7. And this is not a constant, so we see it's not a linear pattern. And then let's take the difference of the differences. 5 minus 3 is 2. 7 minus 5 is 2. Aha. So we're getting a constant in our second set of differences, in the second order differences. That means it is indeed a quadratic. And I think once we verify that this is a quadratic by analyzing the numbers and we see what's up here, a formula should just leap out at you. Each one of these is the step number squared. This one is a 2 by 2 squared. This one is a 3 by 3 square with one square taken out. So I would just write x squared, but then subtract one square from it. So this is going to be our equation, y equals x squared minus 1. We can test it here. So in step 1, that would be 1 squared minus 1. That is 0. In step 2, it would be 2 squared minus 1. 4 minus 1 is 3. Yep, here it would be 3 squared minus 1. 9 minus 1 is 8. This is checking out with the numbers we're seeing. So it looks like a good equation. Let's find step 43 now by just plugging 43 in for x. So y equals 43 squared minus 1. 43 squared is 1,849, and if we subtract 1, we get 1,848 squares in step 43. Well, how did that come out for you? Did you see this pattern? Did you know right off the bat it was going to be a quadratic? Let me know. Thanks, everybody.